Hey guys, this is Miss Adams again. We're still on lesson 2.4. We're getting into solving systems of equations by graphing. But before we can do that, we actually need to see how to graph a linear equation in slope-intercept form. So what is slope-intercept form? We have this y equals mx plus b. So we need to define our variables m and b. M is going to be your slope, which we just learned that's the same thing as the average rate of change. That's your rise over your run, so your change in y over your change in x. And then your b is going to be your y-intercept. So let me change those colors so they match up here. So b is our y-intercept. So that is where your equation, or your function in this case, your linear equation, is going to intersect the y-axis. And remember that your y-axis is your vertical axis, your x-axis is your horizontal axis. So let's go over some of the steps that we're going to take to graph an equation in slope-intercept form. So in order to graph, the first thing you want to do is plot the y-intercept. And remember, that's going to be an ordered pair at 0, whatever that y-intercept is, so whatever your b value is. Your second step is to plot a second point using the slope from the y-intercept. So from that y-intercept, you will rise the amount that it tells you to rise in the slope, and then you'll run the amount it tells you to run. I prefer that you choose more than 2 points, but you can graph a line just from 2 points. From that second point, we could use a slope again to find a third point, or we can use the inverse slope to find to go backwards and find the point behind our y-intercept. I'll show you guys a few different ways in the next example though. So let's go to example 1. We're looking at graphing the line y equals 1/2 x plus 3. So the first thing we have to define is, what is our y-intercept? Well, we know that's our b value, correct? So if I write 3 here, is it wrong? No, but it says to write it as an ordered pair. So if I write that as an ordered pair, I have 0, 3. And let's find that on our graph. So that's a positive value. We're going to go up on our y-axis 1, 2, 3. So we have our y-intercept. Now we have to define what our slope is. Looking at the equation, m equals 1/2. That means we're going to rise 1 and run 2. Both of these are positive, which means we're going to go up 1 and to the right 2. So let's see. I'm going to go up 1 value here, to the right 2, so 1, 2. It's going to be right about there. So we have a second point. We could connect the dots and make a line that way. If I name that point, looking here, I'm going to start with my x value, so that's at 2. If I'm looking at my x coordinates there, and then it's at 4, looking at the y coordinate. Why don't we go ahead and name a third point? So there's a few different ways we could do this. We could use that point that we just found and do the slope again. So go up 1 from this point to the right 2, and we'll have another point there at 4, 5. But you can also do the opposite of your slope. So instead of going up 1 from our y-intercept, I could go down 1. And instead of going to the right 2, I could go to the left 2 and find another point on our graph, because remember, negative divided by a negative is also a positive. So either way, you're getting a positive slope. If I look at that point, it's at negative 2, 2. And then from there, we look at the trend here, that all the points are in a line. So that's how we're going to graph the line y equals 1/2 x plus 3. I'll let you guys try the next one. So we're going to go on to our next example problem. So example 2. It says graph 4x plus 2y equals 12. Well, notice that's not in slope-intercept form, because our slope-intercept form is y equals mx plus b. So we need to put it into slope-intercept form. So we're going to use some of the different techniques that we learned in lessons 2.1 and 2.2 to solve for our y variable. So I'm going to rewrite 4x plus 2y equals 12 here. The first thing we need to do is isolate the variable term. And remember, we're solving for y. So we want to isolate this 2y. Well, I have a positive 4x on this side. In order to get rid of the 4x on the left-hand side, I'm going to have to subtract 4x. And if I subtract something from one side, I have to do it to the other. So I'm using my subtraction property of equality. So I'm going to subtract 4x from both sides of this equation. That'll eliminate the 4x on the left side. So I now have 2y equals negative 4x plus 12. And I'm writing it in this order because if we look at our slope-intercept form, it's y equals mx plus b. So it has that x term, so the term that contains the x, in this case is our negative 4x, in front of the constant, which we know our constant winds up becoming our y-intercept. Last step to do here is to isolate y by itself. Currently it's being multiplied by 2, so we're going to have to do the inverse operation there. Inverse operation of multiplication is division, so I'm going to do the division property of equality, divide both sides by 2, and simplify where possible. So I'll have y equals, well, negative 4x divided by 2 gives me negative 2x, and 12 divided by 2 is positive 6. So that is the same, it's an equivalent equation to 4x plus 2y equals 12, but now it's written in slope-intercept form. From there, I can define my y-intercept and my slope. Y-intercept is your b value. In this case, it's positive 6, so I'm going to have a y-intercept at 0, 6. I'm going to go ahead and plot that as well. It's positive, so it's going to be 6 up on our y-axis, and then our slope is negative 2. Or we can also call this our average rate of change. And remember, any whole number can be written as a fraction or written as a ratio. So this is, I could write this as negative 2 over 1 as well. That way we know that we're going to go down 2, since it's negative, and to the right 1. So let's plot that point. So I'm going to go down 2 from this positive 6 on the y-axis, and then to the right 1 time. So if I'm looking there, I'm going to have my second point at 1, 4. So 1 on the x-axis, 4 on the y-axis. That's what we're looking at, those coordinates there. And let's go ahead and define a third point just to make sure we're doing what we can. So I'm going to go down 2 again. So if I go down 2, that's going to put me at 3, 2 on the y-axis, and then to the right 1, so it's going to put me at 2 on the x-axis. So I now have the point 1, 4 and the point 2, 2. And from there, we can make our line. And that is the graphed version of 4x plus 2y equals 12. And remember, that equation is equivalent to y equals negative 2x plus 6. Alright, now it's your turn. I want you guys to try the U-try problem. So the problem on page 2 and the problem on page 3. And then we're going to get into graphing systems of linear equations.